All right, hey guys, this video is going to be an introduction to integers, which is our next unit, and absolute value. So please take notes as you watch this video. So our learning goals for today, we're going to be learning about integers, and then our success criteria is if you can locate positive and negative numbers on a number line, if you can explain what opposites are, if you can compare positive and negative numbers, and if you can tell me what absolute value means. That's how you will know you are successful. So I want you to think about, where do you see positive and negative numbers in the real world? So where do you see, positive numbers are pretty easy, so maybe more than negative numbers. Where do you see those in real life? Just brainstorm, think of a couple ideas. All right, so negative numbers, you can see them in some different spots. So for temperature, we live in Wisconsin and the temperature gets cold. Sometimes it could be negative 10 degrees outside, negative 20 degrees outside. So a lot of times temperatures, you can see negative numbers. Games, if you play golf, if you make your golf ball in the hole in less amounts than they think it's going to take you, you get a score. Your score can be -1, -2. The lower it is, the better. So in golf, you might see that. Also in football, if a running back loses yards, you might see, hey, they have -10 yards. They lost 10 yards on a run, or a quarterback, or something like that. So you can see it in different sports. Finances, if you lose money or owe money, you might owe $100, so you might see like -100. Another place you might see negative numbers is elevation. So if something's at sea level, it's 0. A mountain would be above sea level, so that might be at like 500. But if it's below sea level, it is negative. So if you have like a valley, the elevation might be -200. So that's another place you might see negative numbers. If you're playing Jeopardy, and if you've ever watched Jeopardy on TV, you also might see negative numbers. Maybe somebody had a score of 500 and they got a 1,000-point question wrong. And their new score would be -500. So if you lose points, you can go into the negative. So those are some places that you are going to see negative numbers in the real world. So you've seen this before, and I don't think I need to go over it too much, but a positive number is any number that's greater than 0. So 1, 2, 3, 4, those are all positive numbers. 4.5, okay, those are positive numbers. Negative numbers are any number that's less than 0. So -1, -2, -3, etc. Those are less than 0. 0 would be neither. So 0 is neither positive nor negative. So positive is bigger than 0, negative is less than 0. If you think of a number line, kind of like a thermometer, we have 0 in the middle. If I'm going up, it'd be like 1 degree, 2 degrees, 3 degrees, 4 degrees. If I go below 0, it goes -1 degrees, then -2, -3, -4. That's kind of how a number line works with positive and negative numbers. Now I can also flip it the other way. I can put 0 in the middle. As I go to the right, it gets bigger. 1, 2, 3, 4. Those numbers keep getting bigger. As I go the other way, -1, -2, -3, the numbers get smaller. So now we're actually going to talk about what an integer is. So you're going to definitely want to write down this definition. So an integer is any whole number. So whole numbers are like 1, 2, 3, 4, 5, not like a fraction or a decimal, that is positive or negative, including 0. So some examples would be like -1, that's an integer, -2, 0, 3, 5, those are all integers. Okay, if you look at the number line I have drawn, again, these are all positive integers on this side. Over here would be negative integers. Then one thing else I want to point out that you probably learned last year is as you go to the right, they get bigger. As you go to the left, they keep getting smaller. So like -7, that's a smaller temperature than -1. This is lower degrees. Okay, so if I ask you to use an integer to describe these real life situations, if I say, hey, you have a profit of 5, well, that'd be like a positive 5. If you lost 5, that'd be like a -5. So those are integers that would describe that. A depth of 8 is if I go down 8, that's -8. A height would be like +4. A decrease of 5 would be like a -5, and an increase of 8 would be a +8. If a number is positive, you do not have to write that positive symbol in front of it. You could just write an 8. So if you take a look at the list of numbers here, some of them are integers, some of them are not. So I'd like you to cross off the ones that are not integers. So integers have to be whole numbers. So any one that's not a whole number, like a decimal, not an integer. Okay, I see another decimal, not an integer. Has to be a whole number, like 1, 2, 3, 4, 5, like you're counting numbers, plus then negatives. A fraction is also not a whole number. So 4/14ths, not whole. 25/53, not a whole number. -8/18ths, not a whole number. The rest of these are integers. Okay, 73, that's a whole number, positive. -594, whole number, negative. 68, 235, and -3,752, those are all integers. So one of our learning goals is to be able to compare compare integers. So I'm just going to draw a little number line here. Okay, so again, as you go to the right, it gets bigger. As you go the other way, it gets smaller. And if it helps you to think of it like a thermometer, you could also draw it that way too. Okay, as you go up, it gets bigger. As you go down, it keeps getting smaller. So one of our goals is to kind of compare numbers on a number line to tell me which one's bigger. So if I look at like 1 and 3, okay, 3 is more to the right, so 3 would be bigger than 1. I can use a little symbol like this. 3 is greater than 1. Okay, now if I look over here, like -1 and 1, obviously 1 is more to the right, so 1 is bigger than -1. I could write that. Now, what if we are comparing two negative numbers? Oops, didn't mean to do that, like -3 and -2. So as you go to the left, it keeps getting smaller. So -2 is actually a higher temperature if you thought of it like temperatures. Or if you owed money, I'd rather owe -$2 than -3. Or I'd rather owe $2 than $3. So -2 is actually bigger than -3. So the further to the right they are, those numbers are bigger. So -2 is definitely bigger than -3. So the next thing I want to talk about is an inequality. You're going to want to write this definition down. So an inequality is a math sentence that compares two amounts. A math sentence that compares two amounts. So basically, if you use the symbols to compare, you've learned these in the past, but this symbol means greater than. If I face it the other way, it means less than. And if you put a line underneath it, so like if I draw that one out, that means greater than or equal to. And this one means less than or equal to. Okay, you have seen these symbols in the past, and hopefully you know some ways to remember it, but I always kind of think the arrow points to the bigger one. So if I was going to write an inequality, I might say, okay, 5 is, I said that wrong before. 5 is bigger than 4, so it points to the smaller one. So you see how it's like pointing at the smaller one? I said that opposite. Some people remember the bigger side is in the open part, but 5 is bigger than 4. That's what that says. If I write it like this, 3 is less than 7. Again, it's pointing to the smaller one. That's how you remember that. I could also write 4 is less than or equal to 4 because 4 is equal to 4, so that's what that symbol would mean. So if I wanted to try to compare some integers, let's see if we can fill in the correct symbols. So I'm going to start with a little bit easier one. Let's start with -3 and -4. Okay, now a higher temperature, you always have to kind of think opposite with negatives. -3 is a higher temperature, so that one's bigger. So I'm going to point to the -4, which is the smaller one. Okay, I'm going to go to letter D over here. 0 is obviously better than owing somebody $5, or that's a higher temperature than a -5 temperature. So 0 needs to be the bigger one. So I'm going to say -5 is less than 0. All right, let's come to this one. So -1 is a higher temperature than -2, so that number is bigger. That's kind of how I think of it. Now, when you get to the decimals, it's a little trickier, so why don't you guys pause the video and you try those three, and then we'll check them in a sec. All right, so the first one, I'm going to think, again, -5.2, that's a higher temperature than -5.3. Okay, it's kind of opposite. If you just ignore the negative signs, the smaller number is actually the bigger number when you work with negatives. So this number is bigger than negative 5.3. Okay, when I come down here, negative 5.90 and negative 5.89. Well, I'd rather only owe somebody this amount compared to this amount. So the negative 5.89 is bigger. And then this last one, I can put a 0 here on the end. Again, if I was owing somebody money, I would rather owe them less than more, so that number is bigger. So there's different ways to think about it, but this is how you compare integers. All right, 2 more things that we are going to talk about, and the first one is something called an opposite. Now, you have heard that word before, so this is not difficult, but an opposite is a number and its opposite are the same distance from 0 on a number line. So if I think 3 and I think negative 3, they are both 3 spots away from 0, so they are opposites. So opposites have to be the same distance away from 0. So if I asked you the opposite of negative 2, well, that'd be 2, because they're both 2 spots away from 0. So why don't you try those 6 questions at the bottom? Can you write the opposites of each number? All right, so the opposite of 10 is negative 10. They're both 10 spots away from 0. The opposite of 0 is just 0. Both 0 spots away from 0. Opposite of negative 8 is 8. This would be positive 235, negative 51, and 103. All right, the last thing we are going to talk about is something called absolute value. So you are going to want to write this one down as well. Maybe you learned this last year, but if you didn't, we're going to talk about it right now. So absolute value is the distance a number is from 0 on a number line. So it's basically how far away is a number from 0 on a number line. Kind of like I was looking at those opposites before. It was like, how many spots away are they from 0? Okay, so if I asked you, okay, here's 0, here's 1, 2. If I asked you how far away is 2 from 0, well, you'd say 2 spots. If I asked you how far away is negative 2 from 0, well, you'd still say 2 spots. That's what absolute value means. Now, here's the symbol for absolute value. It's 2 straight lines, 2 vertical lines going up and down. And I might put a number in there. So that, you read that saying the absolute value of 5 is, well, 5 is 5 spots from 0. If I ask you the absolute value of negative 5, well, that's also, if I was counting on my number line, that's 1, 2, 3, 4, 5 spots away, so it's also 5. Okay, so if I gave you this problem, what would you say the absolute value of 3 is? And how about what's the absolute value of negative 7? Right, well, the absolute value of 3 is 3. It's 3 spots away from 0. And the absolute value of negative 7 is 7. 7 spots away from 0. So just one more little example. If I ask you the absolute value of negative 8, again, if you weren't sure, it's basically just the distance. How far away is it from 0? How many jumps is it? The distance is 8. You can't have a negative distance. So the absolute value of negative 8 is 8. The only thing that gets a little tricky is if I ask you this. Okay, you guys know the absolute value of 5 is 5. 5 spots from 0. But if I put a negative sign out front, that means you're doing the opposite of whatever your answer was here. So I know the absolute value of 5 is 5, and now I'm just going to make that opposite. So if you see it on the outside like that, you solve it like that. Let me give you another one. If I ask you, okay, what's the absolute value of 3? It's 3. But if I put that negative sign on the outside, it means, hey, I want the opposite of whatever your answer is. So I'm going to make that negative 3. So one more, if I say, hey, the opposite of whatever the absolute value of negative 2 is. Okay, so I do this part first. The absolute value of negative 2 is 2. And then I make it opposite, negative 2. All right, so after today's lesson, hopefully you can define an integer and tell me what an integer is or give some examples of an integer. Can you compare integers? Can you tell which one's bigger, such as negative 3 is bigger than negative 4? That would be comparing integers. Could you give me the opposite of a number? So if I say opposite of negative 5, could you tell me what that is? And could you define for me what is absolute value? And could you solve absolute value problems if I give you something like this? We will be using all of what we learned in this video during this unit. If you have questions, please ask your teacher. Otherwise, we will start on our unit tomorrow.